Hey Lauren, how's it going?
Hi. It's going pretty well. Um, Looks like we have three people in the waiting room.
Oh, okay, great. I couldn't see that. I was like, what's going on? But
Oh, I think it's because I tried to make you a co-host, but I don't think it let me. I think it only let me make Blaine a co-host.
got it, got it.
But there shouldn't have been a waiting room, so I'm gonna have to check the settings for like the next one because they're supposed to let people automatically come in. Let's see. Looks like somebody dropped off. Uh,
All right. Looks like we have three individuals here. We're gonna wait another, I don't know, for 3 minutes. And if nobody else joins on, then we'll go ahead and get started. Does that sound good with everyone? Awesome. All right, we will go ahead and get started for the sake of time. No, it is a Thursday evening. Um, Welcome, everyone. Welcome to Air Quality Basics and Understanding Air Quality Data. My name is Charles Romanii. I'm a faculty assistant at the EJ Lab, and I'm delighted to be with you this evening to talk about a little bit about air quality and answer any questions that you may have, and just get into some discussion. So if you don't mind, for all the participants of this workshop, you just drop in kind of where you're zooming in from. It could be general region, state, city, DMV, kind of whatever floats your boat as a little room warmer. PG County, love it. Me too. Hello, Ezra from Garrett County, and then we also have Northern Virginia, EJ coordinator. This is all awesome. Great. Thank you all for joining me. Right. We'll go ahead and get into it. So, just wanted to, uh, take a moment and reflect, right, on kind of the times that we're in, and you know, just think about air quality, right? Just thinking about what it is, right? Tonight we're going to be diving into the world of air quality. We're going to be talking about what it is, why it matters, and how it affects our community, right? Air quality is one of the most important environmental and public health of our time, as you all probably know. Clean air is essential, right, to health, the environment, and even our economy. So it's really important that we reflect, know what it is, and just put our minds, in a great space. I have some reflection questions here. I would love for you all to, I don't know, engage with it, come off mute, just let me know kind of where you're at. Um, these questions are: when did you last check the air quality before going outside? Right? We always check the weather. Like, well, why do you think we check the weather? Um, but we don't necessarily check the air quality. What comes to mind when you see these questions? Ezra, please.
I think of like the fact that I spend a lot of time thinking about indoor air quality and not necessarily outdoor air quality. Because me and my partner, as someone who's COVID conscious, think a lot about like how the quality is inside, but only think about the quality outside when there's a wildfire or something.
Of course.
Like my
Yeah.
friends in Portland and everything have to be very wary when there's wildfires and make sure that they take the proper precautions.
Of course. Yeah. Yeah. Thank you for that. Let's go to Nicole.
Yeah, so like Ezra, previously I only thought about indoor air quality, but unfortunately I do now check for air quality, having been a victim of COVID, and I'm in the long COVID category. So I have a lot of respiratory issues because of that. So I do check air quality before going outside now,
Good.
especially in spring and summer when it's
Definitely.
more stressful on the system.
Definitely. And we'll finish off with Gwendolyn.
Yeah, I echo that as well. I think that I mean I work in an environmental agency, and so I've been paying attention to air quality more since I've started working there. But before that, it didn't really cross my mind most of the time, except in the summer. My youngest child has asthma, and so I would pay attention at the times of year when he was likely to be affected by outdoor air quality because of his asthma, and keep him from going outside and playing. But it's not something that outside of that it's not a habit like it is with the weather.
Yeah. Yeah. I mean, that's so true. And right where I'm hearing environmental reasons, I'm hearing very critical health reasons, right? Our air quality is important. It's important for us to know what the air quality is, not just from an environmental justice perspective, but from a personal health perspective as well. So we can be prepared, just like, hey, if it's raining, I'm gonna bring my umbrella. Hey, if the air quality is poor today for whatever reason, let me make my preparation so I can keep myself healthy. So thank you all so much for those reflections. Right. So just a little bit about air quality. Right. Despite being invisible, right, air carries uh, particles, gases, and even chemicals. Right. That, while we're telling me, can affect your lungs, your heart, and your brain. So really, as we move through this presentation, I encourage you all to just think critically about your own experiences as we talk about certain pollutants. Feel free to come off mute, raise your hand, and just kind of let me know about those experiences with air quality so we can kind of build this conversation, a little bit. So, air quality and pollution, right? Air quality refers to the condition, right, of the air in our environment. Um, sorry, I have a computer. you. Where are my notes? Notes just disappeared. Okay, so yeah, air quality refers to the condition of the air in the environment, and pollution happens when harmful substances like chemicals or particles are present, high enough concentrations to cause harm in the environment. So we measure this through indicators like the air quality index, which I'll talk about a little bit later. Just kind of I'm a huge trivia fun fact person. Studies show that poor air quality can reduce life expectancy by up to 2 years globally, right? So again, another important reason to know about air quality, to know what your local air quality is, know where the sources come from, and kind of prepare yourself in the event that you're facing poor air quality. So where does pollution come from, or where does air pollution come from? So pollution can originate from many sources, right? Some human-made, some natural. In this presentation, we're going to break those down into 4 categories, right? That you see here on the screen. You have your mobile sources, your stationary sources, your area sources, and your natural sources. Understanding the source of the pollution can help you figure out how to control it and ultimately eliminate emission. So we'll take a bit of a dive into mobile sources. So mobile sources include vehicles like cars, trucks, planes, and trains. It's really mobile, right? Things that move that aren't in one place and can cause, air pollution in different areas at different times. There are 3 major contributors to pollution. Excuse me. These mobile sources are major contributors to pollution, especially in urban areas, right? Tailpipe emissions contain a toxic mix of gases and particles, and again, they can really cause harm. Is anyone on the call familiar with any type of mobile pollution source? Maybe there's like a truck route that goes by, or just high levels of traffic near where you live, or anything like that.
Yeah, lots of pollution from diesel fuel trucks at warehouses near um, different communities.
Yes, indeed. We're doing a lot of work here at the EJ Lab with monitoring, doing some air quality monitoring in communities near a lot of those diesel truck operations, and it's so real, right? You can really notice the air difference or the air quality difference. I have a bit of a trivia question for you here. I love popping in trivia questions. Which of the following is a mobile source of pollution? Factory, we have a lawnmower, or we have a volcano. Anybody guess?
Repeat the question, please.
Which of the following that I'm about to say is a mobile source of pollution? You have a factory, you have a lawnmower, or you have a volcano. This is just a fun one. We're for thinking.
Lawnmower?
Yeah, it is lawnmower, right?
Yeah,
It's
I agree. Lawnmower.
you can kind of move it around, especially when it comes to landscaping businesses, right? You're taking that lawnmower to different places, and though it is at a small scale, it is gasoline powered or gas powered lawnmowers are contributing to air pollution. But just wanted to kind of sink in the concept of mobile is moving, right? It includes transportation, cars, trucks, motorboats, but anything that kind of moves and isn't stationary in one place. So next we have stationary sources. Like I was saying, stationary sources do not move. Think about factories, power plants, and refineries. There are many factories and refineries here in the DMV area, right? Especially in Maryland. Right, these sites can emit large quantities of pollutants and are often located near low income or minority communities, right? Raising environmental justice concerns, right? A lot of the work that we're doing here at the EJ Lab is trying to empower those communities, right, with tools and resources to fight back against those injustices, right? One important thing to know, coal-fired plants are one of the largest sources of sulfur dioxide pollution, right? When you think about coal-fired plants in the region, they really can cause a lot of harm to human health. And these are, again, are one of those stationary sources. We have mobile sources so far, those stay the same or stay in the same location. Excuse me, mobile sources that move around, you have stationary sources that stay in the same location. So now we're moving on to area sources, right? Our smaller kind of dispersed sources like residential heating, dry cleaning, or gas stations. And while each contributes a small amount, their cumulative impact can be significant, especially in densely populated areas, right? So area sources, some classic area sources include like farming environments, urban environments, right? Like in one place, but spread out, and they have different things going on. Like think about a farm, different things going on a farm that can cause pollution. Area sources are a big issue as well. And then, of course, finishing off with natural sources. It's important to understand that not all pollution is man-made, right? Natural events like wildfires, volcanic eruptions, and pollen counts contribute to poor air quality as well. And climate change is increasing the frequency and intensity of these events, right? So we're getting it from all angles, kind of in our local communities, from the environment, from the outskirts of town. Air pollution is coming from all angles. And that's why it's so important to understand and kind of know how to support them. So what kind of pollutants are there? So pollutants can be categorized into two types, right? We have primary pollutants that are directly emitted into the environment. You have secondary pollutants that are formed in the atmosphere. The 6 criteria pollutants that you see on the screen are monitored by the EPA, and they include particulate matter, ozone, sulfur dioxide, nitrogen dioxide, lead, and carbon monoxide. We'll go over each of these in the next slide, just to kind of give us, a good, understanding. Again, another fun fact: the Clean Air Act of 1970 established the national standards for these 6 pollutants, for these criteria air pollutants. That's why the Clean Air Act is so important. Clean Air Act of 1970. You also have hazardous air pollutants, as well. They have major health consequences. We may have, an opportunity to go into 1 or 2 of these, but these include, benzene and other hazardous air pollutants that, with these big long names that I'm not going to butcher for you, but these are the ways that you can think about air pollutants. So the first pollutant or criteria air pollutant that we're going to talk about is ozone. O3 is the scientific way of referring to ozone. So or ground level ozone, we can call it, because not all ozone is bad. So ground level ozone isn't emitted directly. It forms when nitrogen dioxide, which we're going to talk about in a little bit, and volatile organic compounds, or VOCs, they come together and react to sunlight, and they create ground level ozone. It's a really powerful respiratory irritant, right? And it's especially harmful on hot summer days, right? Because the sun is beaming and it's really driving those reactions, right? Driving that reaction of the NO2 and the VOCs in the atmosphere, creating ground level ozone. It's in your system and causes a lot of harm. Don't get this mistaken with atmospheric ozone or ozone in our that protects us in our atmosphere, in our upper atmosphere, right? Ozone is great in the upper atmosphere, protecting us from UV rays and things like that. But when it's on the ground, right, or ground level ozone, very dangerous if we breathe it in, right? It's also important to understand that ground level ozone is a major component in smog. When people talk about smog, I'm talking about ground level ozone. Okay, and here just are some of the harmful effects, right? Worsening lung conditions, irritated throat and lungs, greater odds of respiratory infection, other types of breathing concerns. Okay. So now we're moving on to particulate matter, or PM, as it's referred to. We have PM 2.5, PM 10. These numbers refer to the aerodynamic width of a particle, right? So 2.5 is going to be 2.5 microns in diameter. PM 10, 10 microns in diameter. So particulate matter, again, it's made up of tiny particles in the air. And PM 2.5 is especially dangerous because it's small enough to get deep into your lungs and even enter your bloodstream. So sources include construction sites, combustion, cooking, fires, all types of different sources can create particulate matter, can create PM 2.5. And in your lungs and in your bloodstream can cause a lot of harm. PM 2.5 is virtually invisible, right? We have this little diagram here to the right on my screen. And this kind of long strand here shows the width of a human hair. That's about 50 to 70 microns in diameter, microns across in width. And PM 2.5 is much, much smaller than that, right? We're talking about 2.5 compared to 70 microns across. You can kind of understand the scale, right? Off one of your hairs, see how wide it is. You chop that down by several times, and then you have the size of particulate matter, right? Very, very, very small. They can accumulate in your system, cause harm. So we need to monitor it. We need to know what's going on with particulate matter. Moving on to carbon monoxide, our third criteria of air pollutant that we're talking about. Carbon monoxide, or CO, is a colorless, odorless gas that's deadly in high concentrations. It's produced by burning fossil fuels, especially in cars, and malfunctioning appliances. It binds with hemoglobin in the blood more effectively than oxygen, which makes it extremely dangerous, right? Folks in the industry call carbon monoxide the silent killer, right? Because it gives no warnings, before it causes damage. It's odorless, it's colorless. It just kind of comes in and causes harm. That's why it's very important, right? If you live in an apartment or home or house, to have a carbon monoxide detector. Because if you do have carbon monoxide in your home, you won't be able to smell it. You won't be able to see it coming, right? So it's important to have a detector in the indoor for carbon monoxide, so that you can get that alert when carbon monoxide is present. Some of the health effects: reduce oxygen flow, disorientation, fainting. Again, silent killer, death. So that is some information about carbon monoxide. Next, spoke about this one earlier. We have sulfur dioxide, is a gas that comes mostly from burning fossil fuels at power plants or oil refineries. It can cause respiratory problems and contributes to the formation of acid rain. It's especially dangerous for people with asthma. Um, again, harms the respiratory system. And here we have a coal power plant, giving off sulfur dioxide. These huge plumes of smoke gets into the environment, settles into communities, just causes harm, right? So these visuals are important as well to kind of understand how it happens. Next, we have nitrogen dioxide, right? It's a part of a family of gases known as nitrogen oxides. It's produced when fuel is burnt at high temperatures, like car engines or power plants. NO2 plays a key role in the formation of ozone and particulate matter, like I spoke about earlier. People living near highways or really busy roads have significantly higher exposure to NO2, right? People living near highways or near roads, but than those living far away. That's a very important thing to understand about NO2. And again, look at these health effects, right? Like worsening lung conditions, irritation of the airways, the probability of respiratory infection, breathing problems, asthma. These things can compound, right? And these things can really work together to really cause harm to your health. And finally, for our air pollutants, we're going to talk about lead, right? Really, thanks to the phase out of leaded gasoline, lead air pollution has decreased dramatically, but lead can still exist near industrial sites or through contamination in the soil. So that's important to understand. Lead exposure is especially harmful to children. It can affect brain development, IQ. It's just really devastating. PBS has some great documentaries on the impacts of lead on young people in this country, and it's one of the saddest things. Really can really ruin a young person's life. So it's really important we understand what it is, understand how to reduce our exposure, and understand how to get it out the environment. Trivia question: does anyone know the year that lead was banned in gasoline in the United States? Any guesses?
It was in the 1970s, wasn't it?
In the 1970s, it was banned, or it was they did something related to paint, to lead paint, I believe, in the 70s. Lead paint in homes. It's a little later in gasoline. Good guess. Anyone? Going once, going twice. It was 1996, which is not that long ago. What was that?
Sorry, that was just my shocked reaction.
Oh, yeah, no problem. Yes, 1996, not too long ago.
1996, yeah.
Yeah. Lead paint was banned. Leaded gasoline was phased out. So you can only imagine, right? There's still lead in the atmosphere, again, in our soils, near industrial sites. So it's important that we kind of know what it is and continue to monitor it, because it's a lot of harm to our communities. So those are the 6 criteria air pollutants. Was there anything that stood out to any of you? Anything that was surprising? Any pollutant that you may have experience with? feel free to drop a note in the chat or.
Can you repeat the question? It kind of cut out for me.
Oh, no problem. I was just saying we went through those 6 criteria air pollutants. Just wanted to know, was there anything that stood out? You all have, again, as we reflect, right, on air pollution, do you all have experience with a particular air pollutant in any way?
Do you have a list of all 6? And
Yep, I can go back. Goodness, where am I at? Okay, so here are the 6 here: ozone, particulate matter, sulfur dioxide, nitrogen dioxide, lead, and carbon monoxide are the 6 criteria air pollutants, again, that the EPA monitors. I just wanted to know if you all had any reflections on these. And we had one hand raised. Please, Ezra.
So my experience isn't an EJ lens, but growing up on a farm, there's a lot of particulate matter in the air because of all of the grains and hay and, animal dust and dander. There's a lot of particulate matter that way. And also my work in the EJ field, I have secondhand stories and experiences from the communities that I've worked with as well.
Yeah, I do some farm work as well, and between the machinery and combustion, there's a lot of particulate matter that's produced. So thank you for sharing. Anyone else? So I just want to take a look at the chat really quickly. I see we have 2 questions. The first question from Nikki here is, what kind of tools help fight back once those facilities are already near the communities, are already in or near the communities? That's a great question. In my experience, it's really important to collect data, and we'll talk about that a little bit in the coming slides, right? You want to be able to show the problem. And low-cost monitors are a great tool, right, to just monitor what's going on and collect data so that you can have evidence that it's going on. Again, it's crazy that you need evidence when someone puts an Amazon station right next to a neighborhood where people have been living for 50, 60, 70 years. But I would say at a baseline level, just leaning on kind of what we do here at the EJ Lab, right? Like that local monitoring, right? And put a purple air on your front porch. See if anything changes. See if you can get some data, and then recruit that community as well, right? Form some type of community action board or community leadership board or something like that to come together to take the fight on. That's something that we do at the EJ Lab. But these are just some tools and some techniques and some ways that you can go about fighting back, right? Because you're going to need to do that. You can show the data. You're going to need multiple individuals on your campaign so that your concern can get the attention that it deserves. And we have another question here. Ezra, please.
I just wanted to add to that, if that's okay.
Yeah, please.
I put it in the chat, but using, that data and flipping it into a kind of comms story that you can put on blast is another tool that I know a lot of communities facing this kind of EJ harm use. You got to be very particular about who you do it with. But another key factor is knowing what pollutants the company says that they pollute and what they're supposed to be monitoring, because a lot of times in contracts and different agreements, they are required to monitor things that they don't. So having that information can be another tool in your toolbox.
1,000%. 1,000%. Thank you for that addition. So just wanted to move on to our second question here. Nicole asks, with all of the federal roadblocks on regulations, will these pollutants still be monitored by the EPA? I mean, from where I sit, I don't know, but I mean, we just went through 6 criteria air pollutants and all of their health effects, and I hope, right? I hope because it's extremely important, right? When we think about the health of our communities, the health of our family members, we need to know what's in the air, and our government has a responsibility to kind of oversee those things. And it would really suck. Right? I mean, what's going on right now, kind of in the political arena is frustrating, right? Especially with the direct attack on environmental justice. But I can't really answer that. I don't know. I'm monitoring it closely, right? I staying update with the news and everything, trying to understand where this thing is going to go. But it would really be harmful, right? If a lot of these um, um, if the EPA decided to no longer monitor these, that they would need some type of explanation. I don't know what type of explanation you can get for not monitoring the criteria. So thank you for that engagement, folks. So just wanted to talk a little bit about interpreting air quality data. Again, today we're just scratching the surface with a lot of these topics. And in our workshops to come, we'll try to dive a little deeper. But reading air quality data really starts with identifying, the pollutants, like Ezra was just talking about, right? Like identifying, knowing what you want to measure, knowing what to look for, right? So whether it's PM 2.5, ozone, nitrogen dioxide, you really want to understand, hey, what pollutant am I dealing with, right? Before you can into interpreting air quality data. Units like micrograms per cubic meter or parts per billion, sometimes parts per million, tell us the concentration, right, that are in the atmosphere. And you want to check whether your data is averaged over an hour or over 24 hours or maybe a longer period of time, right? That ultimately is going to affect how we interpret impacts of the pollutant, right? And ultimately, you always want to compare the number that you have monitored or that you have to some type of health-based guideline, right? EPA standard or another air quality standard, maybe who the World Health Organization air quality limits, so you can get an understanding of where you are in relation to that threshold. So that brings us to the air quality index, or AQI, right? Which is just a standardized system that tells us how clean or how polluted the air is and what the associated health risks are. It really simplifies multiple pollutant measurements into a single number or a color scheme that's easy to understand and easy to read, easy to interpret, right? So this is a great index or a great tool to know, right, if we want to check the air, right, before we leave the house, right? You can think of it like a traffic light for air, right? Green means go, yellow means caution, red means stop, or at least avoid strenuous outdoor activity, right? A lot of times we can't stop. We gotta go to work. We gotta, take the little ones to school. We have to do something. But you kind of want to know where you are in relation to these color codes. Each level is based on concentrations of the 6 common air pollutants, with the most harmful, 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 6 common a determining the overall AQI for a location. So again, the scale goes from 0 to 500. And yeah, you wanna kind of read this like a traffic light. Green, you're good to go. Purple air or hazardous air, you really want to think twice before engaging with outdoors. This model of the AQI was first introduced in 1968, and the modern version that we're kind of seeing used today was popularized in the 1990s. And I just wanted to finish up, round things off with some tools to explore air quality data, some easy tools that you can go in today and just start to mess around with to get a better understanding of air quality data. There are many tools that you can use to explore real-time and historical data trends. Air Now is the official source in the United States, and it offers air quality index forecasts. I did check it. It is still functional. Thank goodness. So you can use Air Now. Purple Air, right, provides those hyperlocal sensor data from community members, right? So it's a great way. I check the Purple Air network all the time. There are people in my neighborhood, right, who have Purple Air sensors, right? So it's just a good way to get an understanding of the air quality, like just right around you, right, at a very, very local level. The Purple Air crowd map, really wherever you are to get an understanding. Open AQ gathers global air data for researchers and the public. So that's a good one to know. And then newer sensors even sync to your phone, and you can track conditions as you go. Those like get air monitors, or those mobile air monitors are and you sync those up with those apps, Bluetooth or Wi-Fi, and they can kind of measure your air quality as you walk through communities, and as you walk through time. So again, just 4 really simple resources that you can use to empower yourself, right, on your daily journey, and you get a better understanding of air quality. Our citations, and that's what I had for you all today. Again, just wanted to give a introduction, right, to some of the air quality basics and some of the work that we do here at the EJ Lab. Please stay on with us through this journey of doing our workshops and engaging with the community. We'll be going into some information about particular sensors, calibration, sensor deployment. We'll get into the specifics and the nitty gritty of things, as we go throughout these workshop series. But that was the presentation I had for you all tonight. Were there any questions or anything like that I can answer?
Can you show us the purple air map really quickly before we go?
Yeah. Yep, sure. Let me stop sharing. Okay. Purple air crowd map. Share my screen. Okay, can you see my screen okay?
Yes.
Yes.
I can see it.
Yep, so I just went to Google, typed in purple air crowd map, and you can see all of the community members and organizations really across the world, right? Who have purple air monitors and who are doing, hyper local air quality monitoring. And zoom in on our area. And you can use this map to just get an understanding of, what's going on in the DC, Maryland, and Virginia area. Again, we want to see green. If we see yellow, take a little bit of caution. If we see red, hey, what's going on here? So again, just a quick way to get an understanding. Hey, I might be in Southeast DC one day. What's going on? I might be uptown in DC. What's going on? Maybe I'm in Northern Virginia. What's going on here? Just a good way to kind of keep yourself updated on what the air quality looks like at a local level. So, yep, I encourage everyone to go and check it out, and if you don't have a purple air monitor, kind of look at them. They are technically considered low cost monitors. I think they're around $200 or $300, so not exactly cheap, not as expensive as some of those government reference monitors. And they're really cool, right, to have, and just again empower yourself with some information before you go out about the day. We had another question here from Michael. Do you know if there are any projects that focus on air quality monitoring outside of daycare facilities? It's a really great question. Michael, I don't. At the moment, is Michael along with us? I don't know of any projects that currently focus on air quality monitoring outside of daycare centers. It will be interesting to connect with the Children's Environmental Health Network. I know they're really focused on environmental health issues and particularly air quality issues, related to children. So that might be a good. But yes, that is a lot of monitoring, Nicole. And Nicole, I do see your question, and I'll follow up with you on that, your message. But thank you all for the time tonight. Hope to see you on the next one. We'll be talking about kind of a different aspect of air quality. And yeah, again, for the rest of you.
Do you have the link to sign up for the next webinar?
Lauren, well, she'll pass that one around
Okay.
after the session. Yeah, she'll make sure everybody gets it.
Yeah, I'm gonna drop my email in the chat. And then so just shoot me an email, but I'll be sending that out via MailChimp and GroupMe. It'll be on our social media. And then this will also be posted on our YouTube page along with our GIS workshops if you just want to like recap on everything.
So thank y'all so much.
Yeah.
Thank you.